In this video, we're going to have a look at stacks. And if you remember back to the previous module, we looked at the difference between the stack and the heap, which the compiler uses to allocate memory to. Remember that the stack is used for small amounts of memory, such as variables and function pointers, which are stacked upon each other as the program executes. We're going to be doing something similar to that with creating our own stack, but rather than storing the variables and function pointers of our program, we're going to be using them to model stacks of data, or perhaps to represent physical items in code, such as perhaps a stack of plates, or a stack of delivery boxes, or whatever particular system or entity that we're trying to model in our code. And so the key principle about the stack is that items are added onto the top of the stack. And therefore, to actually get access to items, they also have to be removed from the top of the stack. We don't remove items from the bottom of the stack or from halfway through the stack. So therefore, a stack is referred to as a last in, first out structure, as opposed to the queue, which is a first in, first out. Remember, a few videos ago, we said that with regards to the queue, people or items join the queue from the back of the queue, and then they exit from the front of the queue. So therefore, the first person or first item in the queue is the first to exit the queue. Whereas with stacks, the first item, entity, object, whatever, to be added to the stack is therefore the first item to be removed from the stack. And so by definition, if you need access to an item which is in the middle of the stack, you'd have to remove all of the items which are stacked on top of that middle item to be able to get access to that middle item. Okay, so a stack tends to be implemented with an array. It doesn't have to be, it should be said, it's not exclusive to an array. You could use a linked list if you want to. You could stack linked list nodes, or indeed implement a stack with a vector. But a stack tends to be implemented with an array because the items in the stack don't tend to be reordered in any way, unlike linked list nodes, which could be reordered or items could be inserted in the middle of the linked list. Whereas, remember with our stack, we're only adding items onto the top of the stack, so therefore we don't need to worry about removing items midway through the stack or at the bottom of the stack. So therefore, an array of fixed size tends to be preferable for implementing stacks. And of course, as our arrays are indexed, we can use this index to keep a track of the last element that's been added to in our array, or in other words, the top of the stack. And so we therefore have a variable in our stack which is used to store the index of the top element. And as you can see here on this diagram, if there are no items in the stack, top will have the value of -1. And then when the first item is added to the stack, because that item is stored in the 0 element of the array, top would then be incremented to become 0. And then from there, as we keep adding items to the stack, we keep incrementing the value of the top variable so that it refers to the top element of the stack. This is what we refer to as the top pointer. Of course, it's not a literal pointer. It doesn't point to the memory address of the element. It's just referred to as a pointer because we continuously update it to point towards that top value of the stack. So next, let's have a look at the UML class diagram for a stack. And you can see here that the variable referring to the top of the stack is listed here in the attributes. Other attributes we have are the max size of the stack, which of course is referring to the number of array elements that we've specified. And then we've also got an actual pointer. You can see the asterisk under the data type there for stack data. And if our stack is of integer values, then we'd create an integer pointer, and we've just got a reference here called stack data. Of course, that could be anything. Okay, so those are the attributes. Next, let's have a look at the typical methods we see with a stack. First of all, our constructor, the method with the same name as the class, is used to initialize the data structure. as always. So in this case, the stack constructor is going to initialize the array, and it's going to initialize it of the size which is passed to the constructor. So when we come to instantiate the stack data structure, we pass in the number of elements that we want to create the stack of, and this number of elements is going to be passed to the max size variable here, and then we create the array of that size of elements. And next, we have some methods which will query the stack to inquire if it is empty or if it's full, and we return true or false depending on the outcome of that. And we also have another method which returns the number of elements in the stack, the maximum number of elements in the array. And then we have the push method. Push is another term for insert, and that's where we're going to add the item onto the top of the stack. So of course we have to refer to our top pointer to know which element to insert this new element into. And then next we have the pop method, which in some cases it removes the item from the stack. It actually deletes the item and changes the index. In other instances, it just changes the index and later overwrites the value of these elements if they haven't been deleted. Okay. And then alternative to pop, we can actually just look at the value of the top element, which is what our peek method does. It doesn't actually remove this value or change the pointer. It just uses the pointer to refer to the top value of the stack. Okay, so finally, the rules of the stack are as follows. The newly initialized stack is considered to be empty. And then immediately after pushing an item onto the stack is no longer empty. And then of course that item becomes the top of the stack. And then immediately after popping that top item off the stack is then considered to be empty again. Okay, so this has been a brief explanation of a stack. In the next video, we'll have a look at coding a stack. Right, so let's have a go at the first exercise then, which is to implement the stack class. And we're given the UML design here for this, so let's go ahead and do that. I'm going to go to project and add a new header file for the stack. And we're instructed to call it stack1, which presumably is to prevent us from interfering with another class called stack. It's possible that that's already been defined for us, but this is still going to be a useful exercise because creating a stack from scratch is, and certainly having questions on the stack are very common interview questions. So it's important that we know our way around the stack and are able to create one from scratch if we're required to. So let's start by implementing the attributes, and we're given 3 here. So I'm going to declare these in the private interface, and the first one is max size, which is going to be useful if we're using an array because we want to define how many elements that are going to be in the array. Next is a integer pointer to stack data, so presumably this is going to be our pointer to the array, which we're going to initialize in the constructor. And then finally we've got an integer variable to keep track of the top element, okay, which we're going to increment and decrement as we push, basically insert items onto the stack, and pop, which is removing the items from the stack. Okay, and so next then, let's implement the methods. And we're given the pseudocode here for the different methods. So let's start with the constructor, which is, it's a non-default constructor because we're going to take in the size of the array. So let's set that up here. Int max size. And let's have a look at the pseudocode. So set max size, that's going to assign the parameter max size to the class variable max size. So let's be specific and say the class max size is going to be set to the value of the parameter max size. Okay, that's that. And then next we're going to want to instantiate stack data. So we're going to want to say stack data equals new int of the size. Okay, and you could say max size or this max size, they'd both be the same. Okay, and then next we want to set top to have the value of -1. Okay, because particular way that we're writing this, the method we're going to come on to next, which is push, we're going to increment top before we then assign the element. So let's do that now. And having a look at the signature, we've got a void return type, and then we've got a parameter into an integer variable, which is going to be the value that we push onto the stack, we insert onto the stack. So as I just said, we're going to increment top and then set the top element of stack data. Oops. Stack data referring to top as the index, and then assign it value. Okay, should be that. And then next we've got pop. So let's have a look at the signature. And yes, we've got an integer return type because we want to remove the item. Well, we've actually got a choice because we could actually remove the item, as in to reset the value of that array element, or we could simply change the top pointer, and then when the top pointer goes up to that element, it would just overwrite it again with a new value. So we've got two options there. Let's have a look at the pseudocode. Here it just returns the top element, the value of the top element, and decrements top. So it doesn't actually remove the item. Okay, that's not a problem. So we'll do that. So we're going to, well, probably best if we store the item that we want to return before we then decrement top. So let's say item to return equals the top element of stack data and then we're going to want to decrement top and then return item to return. Okay, that's one. There's different other ways you can do that, of course, but that's just one of the more stepped out ways where everything's visible. So let's move on then and have a look at peak, which is going to be very similar to pop, but it just doesn't decrement the top value. It just returns the value so we can look at it, but it doesn't actually remove it from the stack per se. All right, and so it's also going to have an integer return type, peak, and that should just be return top element. Yeah, so return stack data top. Okay, that's that one. What's next? IsEmpty. Okay, so we should be familiar with these methods by now. IsEmpty and IsFull, similar to linked lists and other ways that we've looked at them in the past. They're just going to be methods that return a Boolean value for whether the stack is empty or is full. Okay, so these are going to have bool return types, and IsEmpty is going to say, well, if top has the value of -1, then return true, else must be something in it, so return false, it's not empty. Okay, so that's that. And then finally for IsFull, it's going to be a very similar method, but here we're going to want to say if top has the value, I mean that's pseudocode, but just to be specific there, if top has the value of max size -1, then return true, else return false. Okay, so that should be all of the methods there. All right, so the final bit of the first exercise is to create an instance of the stack in main and add 4 values to it. And then within a loop, we want to display those values. Okay, so let's do this then. And first of all, I'm going to need to include the reference to stack 1. And then I'm going to want to create an instance of stack 1. So let's just call it S for short. Just new stack 1. And I'm required here to specify the number of elements that we're going to have in this stack array, which is 4. And then we can go ahead and call the push method and add some integer values onto it. So let's just copy this for 3 other times, and then change the values. Okay, so we've added them, and then we just have to write. We could call pop 4 times, but there's a more efficient way of doing this. So we could repeat whilst s dot IsEmpty is false. Okay, and then we just want to see out the return of pop. Okay, so let's give that a try. Loading. And there we go. There's our 4 values, which were inserted, which were pushed onto the stack, and then we've just popped them off the stack. We've popped them off and printed them to screen. Okay, so there you go. That's the first exercise then, creating a basic stack. Have a go then now at the other exercises, exercise 2 and 3, which take it a bit further. They require you to create a template version of the stack, and also have a go at creating a linked stack where you combine a linked list with a stack as well in the third exercise. So give that a go and see how you get on.